In this video, I'll be solving the first problem of UPSC Civil Services Mains Statistics Paper 1. So we were given like E, F and G are three pairwise independent events such that probability of E intersection F is 0.1 and probability of F intersection G is 0.3, and we are asked to prove that probability of E complement union G is greater than or equal to 11 by 12. So if we consider, so they have mentioned that they are pairwise independent. So that means probability of E intersection F is probability of E into probability of F, and probability of F intersection G is probability of F into probability of G, and probability of E intersection G is probability of E into probability of G. So let us consider probability of E is some Q, or like let this be P, and probability of F be Q, and probability of G be R. So that means from the given data, so we were given probability of E intersection F is 0.1, so that means P into Q is 0.1, and F intersection G is 0.3, that means Q into R is 0.3. So that means like P is 0.1 by Q and R is 0.3 by Q. R is 0.3 by Q. So now like we need to find the lower bound for probability of E complement union G. So probability of E complement union G, so that is nothing but 1 minus probability of E intersection G complement. So that is nothing but 1 minus probability of E intersection G complement is probability of E minus probability of E intersection G. So that means this is 1 minus probability of E plus probability of E intersection G. So we already know what is probability of E intersection G, which is nothing but P into R, and probability of E is P minus 1. So basically this is what 1 minus P plus PR, so that is nothing but 1 minus P into 1 minus R. So we need to find the lower bound of probability of E complement union G. So that means we need to find the upper bound for P into 1 minus R. So if we can find the upper bound for this, we can just find the lower bound for this entire quantity. So if I consider P into 1 minus R, so that can be written as 0.1 by Q into 1 minus 0.3 by Q. So that's nothing but 0.1 by Q minus 0.03 by Q square. So if I consider this function as some f of Q, so now I need to minimize this particular thing. And we also should not forget that Q is a probability quantity. So that means 0 less than or equal to Q less than or equal to 1. And the second thing is R, the probability of R is also less than or equal to 1. And even Q is less than or equal to 1. So that means Q is greater than or equal to 0.3 and Q is greater than or equal to 0.1. So that means from these two conditions we can say Q. So from these three conditions 1, 2 and 3, we can say Q belongs to 0.3 to 1. So that's the range of Q, and we need to minimize this particular function in that range. So if we find f dash of Q, so if we make f dash of Q is equals to 0, so that means 0.1 by minus 0.1 by Q square plus 0.06 by Q cube is equals to 0. That means Q is nothing but 0.6, and 0.6 is lying in between our feasible region 0.3 to 1. Now if we find the value of f at that particular point, that is 0.1 by 0.6 minus 0.03 by 0.36, that is 1 minus 6 by 1 by 12, which is 1 by 12. And in the same way, if I consider f of 0.3, so that is 0.1 by 0.3, just taking the extreme boundaries, so 0, 9, which is 1 minus 3, 1 by 3 minus 1 by 3, which is 0. Now in the same way, if we compute f of 1, so that is nothing but 0.1 minus 0.03, which is nothing but 0.07. Hence the maximum value of f of q on, so hence the maximum value of f of q on 0.3 to 1 range is 1 by 12, and this is attained at the value q is equals to 0.6. So we have found p into 1 minus r is less than or equal to 1 by 12. So if p into 1 minus r is less than or equal to 1 by 12, minus p into 1 minus r is greater than or equal to minus 1 by 12. So that means 1 minus p into 1 minus r is greater than or equal to 11 by 12. So that implies probability of E complement union G is greater than or equal to 11 by 12. Hence we proved that probability of E complement union G is greater than or equal to 11 by 12. So that's it for this video. We'll meet in the next video.